I'm going to show you how to do an iterative in-order traversal of a binary tree. Usually this is done in a recursive way, but it's a good exercise to do it iteratively and learn how it can be done in both ways. So first of all, what is in-order traversal? So in-order traversal is when you visit first the left node, then the left child, then the root node, and then the right child. This is very easy to see in a recursive way. So if we do it recursively, it would be, for example, if we had this function in-order traversal, we would do first in-order traversal of root left, then we visit the root node, and then we do in-order traversal of the root dot right. So this is how to do it simply. So let me show you how this looks when drawing this out here. So that means that you start at the root node, but you don't actually visit the root node yet. You go to the second node, to the left one. Actually, also don't visit it. Go to the number 4, don't visit it, and go to the number 8. And now you try to visit the left one, but there is not a left one anymore. So you visit this one, then go up and visit this one, then go up and visit this one. And now you would actually go to the right, but not visit 5, go to 9, visit 9, then visit 5, and so on. This is what we're going to try to accomplish in an iterative way. So to do this, we're going to use a stack, okay? So we'll have a stack where we will add our numbers. And the stack in Python is simply a list. And then we have a variable node, which at the beginning we set equal to root, and then we will start to change it. And we start a loop. So we say while true. And here what we're going to do is we're going to try to find always a left node before we start visiting. So we will, inside this while loop, we do another while loop, and we do while node. We append the current node to the loop, so to the stack, sorry. So we do stack append node, and then try to go to the left. So we do node, node is equal node.left. So what this will do is this will bring us all the way to the number 8, okay? So we will start at 1, and then we will append it here in the stack. So now the 1 is here. Actually, I usually do this when I visit it, so we're not going to visit it yet, because now we do node equals node left, and then we go to the next one, and we add it also in the stack. Then go to the next one, add it to the stack, and then go here. Okay, and then notice that what happens now is that node at this point is equal to none, because there is no left node here. So now we will break from this loop. And what do we do when we break from this loop? First, we need to check whether or not we are whether or not this tag is empty. Okay, so we do if not stack. So if this stack is empty, we return. We reach the end of the process. However, if it's not empty, what we do is that we're going to do node equals stack dot pop. Okay, so that means that we're going to take one of these numbers here. Actually, we forgot to add them here. Okay, so that means that now node is going to be equal to 8. And then what we do is that it now is actually that point when we visit it, okay? So now we can say visit node. And visit can be just a simple function where you print the value. So then you would have an output, and now we would print the number 8. And then after visiting it, what we will try to do is to go to the right node. So now we would do node equals node dot right. Okay, and this is actually all of the code. So now you see that in this case, node is going to be none again, because there is no right here. This is none. So we will go back here, and then this is going to jump until here, because this is none. And the stack, there is something in the stack, by the way. The number 8, we had to pop it from the stack, so we remove it. Okay, so yeah, we also cross this. And now the next node is number 4. Okay, so this is 4. So now we would print 4. So this one we have visited, and now we are visiting 4. Okay, so we have visited it, and now we again try to do node.write, but there is no node.write. So we are going to pop the number 2 again. Then we are going to visit it. But then the interesting thing is that when we get here, actually we do have a right number. So this is going to be the node 5. So now we go to node 5, but we are not going to visit it because note that here we are appending it to the stack. I forgot again to remove the number 4 and the number 2. It looks like this. And now note that now we append the number 5 to the stack here, but we don't visit it yet. We actually go to 9, okay, because we do node equals node dot left. Now, because there is nothing here, we're going to visit 9, okay. We were printing, so we already printed number 2, we visited it, and now we're going to print number 9, and then from 9, so 9 goes in the stack and then it's removed again. So we would have 9 and then we remove it. Now we pop this number from the stack, so we would pop number 5 here. We would visit it, we would visit number 5, and because there is no write, we would, okay, now this is visited, and now we get here again, and because there is, here we are at none, because 5.write is none, then we need to pop another number from the stack, and then you see that the next number is 1. So from 5, we go directly to 1 and remove this one. Okay, so now we have an empty stack. And now we get here again, so we visit 1. The 5 we already printed before, now we print 1. And now we are going to visit 1.write, which is 3. Okay, and then we are in, this is not interesting anymore, then you would be at 3, and it's the same process all over again. So you don't visit, you actually, this is wrong, you don't visit 3, you go to 3, but you append this to the stack, and then you go to 6, visit it, and continue like that. So that's the idea. This is the code. As you can see, it's more involved than using the recursive way, but that's also why it's an interesting exercise. So I hope this was useful, and if you have any questions, you can leave a comment. Thank you for watching.